In today's video, I'd like to explain LSTM, which is kind of like advanced version of simple recurrent neural network, which I made a video about it previously. And my the code for LSTM I've written this time is almost exactly same with the code I've written for recurrent neural network. So if we were to compare the codes, it's almost identical, except this time it would be LSTM. I mean, I'm gonna be using LSTM class. So, like I said, it's almost same as before. I use Apple stock price data set and do normalization and splitting into test, train, and test, and make sequences. And I initialize the LSTM class and train and do evaluation and prediction and get the result. So same as before, in the constructor I just initialize parameters, weights and biases, but this time, because LSTM itself is pretty complicated, I have to initialize pretty like lots of them, and this is for the atom optimizer, so it's pretty a lot this time if you were to compare it with recurrent neural network. And in the train function, as always, I just first run the forward function, which is this one. It's almost exactly same as before, except the how forward is propagated. So this is forward gate, which determines how much hidden states you'd like to keep it, and you use a sigmoid to do that. If this output 0, it means you discard the values, and if it 1, it means keep the values. And this is input gate. This determines which values to keep it from this candidate called C tilde. So you multiply forget and previous cell state to determine which information to discard, like irrelevant values, or values you don't need for the training. And for this, this calculation means which values to keep it for better training. This is kind of like memory, I guess. I'm not fully understanding, but and you also calculate output, and you multiply with output of hyperbolic tangent of this cell state. This is kind of like final result at the time step, in each time step. And as always, you use, this is kind of like a dense layer in TensorFlow in order to match the dimensions, like shapes. I think I explained this in previous video. And I have to return all of these, almost all of them, from this function in order to do, in order for me to compute partial derivatives after this forward function. So that these are all the values returned from the forward function. And yeah, this time, because number of parameters used in this model is quite a lot than previous model. I have to do more calculations for it to get gradients. So I have to calculate DL, DHT for each weights. In simple recurrent neural network, I only had to get single DL, DHT, but this time I'd have to calculate DL, DHT for each parameters. But rest of them are quite same, I guess. But yeah, but partial derivatives for this was, yeah, I would say harder than previous one. But I guess it's essentially the same. You just backpropagate, but this time more parameters. And unfortunately, I thought I don't need to use atom optimizer because I thought LSTM is more advanced, but it wasn't true that I had to use atom optimizer again. And again, this is huge, lots of calculations because of number of parameters, like I said. I should have run the program because it's really slow. I was gonna run the code in the beginning of this video, but it seems like I forget it. But I think it's fine because I already did it like several times for that, and as you can see, but unfortunately, like I said, the result isn't as good as simple neural network. I think for this kind of data set, it's too small for LSTM, and also the sequence length is 10, which is also not long enough to take advantage of power of LSTM, I guess. But it's, well, at least it's working. This is the result if I use TensorFlow with LSTM. So even with TensorFlow, the result is pretty bad. I mean, not as good as the one you get with simple neural network. So yeah, I think this is it for today's video, and I guess for next video I've started working on implementing GRU. So yeah, after I'm done with it, I think I'm gonna make a video again. But I guess that's it for today's video. Thank you.